Show that an Euclidean domain an element is prime if it is irreducible. Solution: let D be a Euclidean domain. Since we know that every Euclidean domain is principal I domain, so D is a principal I domain. Let P divides D be a prime element. We needs to prove only that if P equals to AB, then A and B is unit. So let P equals to AB, then P divides AB, which implies P divides A or P divides B. If P divides A, then P equals to A equals to Px for some x, because of P is prime. So P equals to AB becomes P equals to PXB, P equals to X, PA equals to PX into B, which implies P minus PX into B equals to 0, which implies taking P common into 1 minus XB equals to 0, which implies 1 minus XB equals to 0 as P not equals to 0, so which implies XB equals to 1, which implies B is a unit. Similarly, if P divides B, then A will be unit. Conversely, let P is a irreducible element and suppose that P divides AB. We show that P divides AB or P divides B. If P divides A, then there is nothing to prove. Suppose if P not divides A, since P and A are the element of principal ideal domain, so they have a greatest common divisor, say D. So we show that D is a unit. Now D divides P and D divides A there, which implies there exists U and B such that P equals to DU or A equals to DV. If D is not a unit, then as P is a irreducible, P equals to DU. U will be a unit, so which implies U inverse exists, which implies P into U inverse equals to D. So A equals to P U inverse V, which implies P divides A, which is not so, thus D is a unit. Again, we know that D can be expressed as D equals to lambda A plus mu P, which gives D into D inverse equals to D inverse lambda A plus D inverse mu P, which implies 1 equals to D inverse lambda A plus D inverse mu P, which implies B into 1 equals to lambda D inverse AB plus mu D inverse BP, but P divides AB, P divides mu D inverse BP, so P divides AB lambda D inverse plus mu D inverse BP, which implies P divides B into A lambda D inverse plus mu D inverse P, which implies P divides B by the definition of the divisibility. Hence the result follows.